Good morning. This is your homework video for section 3-2. We're on page 199. For numbers 17 through 39 odd, we are starting out by converting from logarithmic form. So let's see. Alright, so if this is logarithmic form, to go to exponential form, I just sort of make this triangle. So b to the n equals x. So it's not even really a triangle, it's sort of a circle that I visualize my base to my power equals my answer. So in number 17 we're given 81 to the 4th power equals 3. So that's in exponential form, so I want to change it into logarithmic form. So b to the n equals x, so my b comes down here. So my log base 81 to the 1/4 power equals 3. In number 19, 6 to the negative 2 equals 1/36. So I've got my log, my base is 6 to the negative 2 power equals 1/36. In 21, g to the a equals 4. So in logarithmic form, I've got my base, log base g to the a power equals 4. In number 23, we're actually, it looks like a calculator thing. No, definition. Alright, anyway, let me copy it down. F of x equals log base 2 of 16. So it was log base 2 of x, and I plugged in the 16. So in order to solve this, I'm thinking of this in terms of exponential form. So 2 to the what gives me 16. Well, I know my powers of 2 by heart. You might not, but it goes 2, 4, 8, 16. So I know that 2 to the 4th power equals 16. For number 25, I've got the log base 10 of x, and x is 1/1000th. So basically I'm saying 10 to the what power gives me 1/1000th. And now you guys, if you don't do exponents in your head, you're at a little bit of a disadvantage. But let's just count by powers of 10. So 10 to the 1st is 10, 10 squared is 100, 10 to the 3rd is 1,000. So if we were to go into our negative powers here, 10 to the negative 1 is 1/10, 10 to the negative 2 is 1/100th, 10 to the negative 3 is 1/1000th. So 10 to the negative 3rd is 1/1000th. So I'm demonstrating these. I'm hoping that you will gain some number sense and be able to do some of these exponents in your head. It's going to make this whole chapter a lot simpler if you can gain a feeling for how exponents work if you don't have one already. In number 27, we have to use a calculator. And that's because we're doing log base 10 of 345. Obviously 345 is not an even power of 10. It's in between. So part of what this is trying to get you to understand is that in your calculator, if you look at the log button, let me move it up here, the log button has the inverse right above it, 10 to the x. So that serves as a reminder that the log base in your calculator is a base 10. So if I just punch in log of 345, that's going to tell me 10 to the what power is going to give me 345. So basically 10 to the 2.54, 2.54 is my answer. And number 29, I've got h of x equals 6 times log base 10 of 14.8. So 6 times log of 14.8. And I don't really need to put in the 10 because it's understood base 10. So that is 7.02. In 31, log base 7 of x equals log base 7 of 9. So this is using the properties of logarithms. If I've got two equivalent logs, log base 7 of this equals log base 7 of that, then I can drop the logs. In 33, log base 404 squared equals x. So I am going to rewrite this in exponential form. So that way it'll be more obvious what the answer is. 4 to the x equals 4 squared. So so you see how I rewrote it in exponential form, and now isn't it obvious that x equals 2? Because we really just want our powers to be the same. Okay, so number 35, let me get a new paper here. Got the log base 8 of x equals log base 8 of 10 to the negative 1. So basically I've got log base 8 of a thing equals log base 8 of another thing. So the best way to do that is to drop the logs. 10 to the negative 1, we said earlier, is 1/10. In number 37, I've got to use the properties to simplify. So let's see what we can do. Log base 4 of 4 to the 3x. So let me flip back and check in this chapter which properties they're talking about, because I feel like there are some properties that we haven't learned about that I'm tempted to use. Okay, so if I'm looking at my properties of logarithms, property number 3 says the log base a of a to the x. So that's when the base and the base of your exponent match equals x. So then that means a to the log base a of x equals x. So I prefer to read and interpret this one right here. When these two numbers match, then the answer is what's up in the exponent. So I'm going to look at it like that. In number 39, we have 3 times log base 2 of a half. And so what I'm going to do here is I'm going to rewrite a half as 2 to the negative 1. So see here, that way I was able to get these two numbers to match, and so I can replace this whole thing with a negative 1. So 3 times negative 1 is negative 3. Now I'm going to do 43 to 53 odd. So sketch the graph of f and g. So in 43, f of x is 15 to the x power, and g of x is the log base 15 of x. So (15 to the x) is, so if I start out at 0, it equals 1, and then as soon as I go to the power of 1, I'm jumping way up to 15. So this is a pretty steep exponential. And so the log base 15 of x so let me see what I can do on my graph here. I'm going to do the log of x divided by the log of 15. And I've got to change my window from earlier. I want to go back to negative 10, 10, no, negative 10, enter, 10, enter, enter, negative 10. Okay, so let me zoom in just a little more. I'm going to go x equals 0. And x equals negative 2. Negative 5. Alright, so that'll be a better zoom. So you can see that it crosses over at 0, 1. We've got an asymptote here. And then we're going up very slowly here. So what this problem is meant to demonstrate is that these guys are inverses of each other because they reflect. It's a reflection of this line of y equals x. So that's what happens when we have inverse functions of each other. And as you can see all along in these problems, we've been converting between exponential and logarithmic form. They are opposites or inverses of each other. So in number, with that being said, I hope I don't have to do too many more graphs. Oh, of course I do. Alright, so in number 45, y equals log base 2 of x plus 2. So what I'm anticipating here is that this is 2 to the left of the parent function. So I need to find the domain, the vertical asymptote, and the x-intercept of the logarithmic function. And then I need to sketch it by hand. Okay, so since we're going 2 to the left, we kind of want to think about what the domain is of the parent function. And let me sketch the parent just really lightly on here. The parent function would have this critical point at 1, 0, and it's got a vertical asymptote at the y-axis. So if the new function is the exact same and it's just 2 to the left, I would come over here to negative 1, and that's my new x-intercept. And so my old asymptote was 1 to the left of my x-intercept. So if my x-intercept is at negative 1 and I'm shifting everything 2 to the left, my new vertical asymptote is at x equals negative 2. And so in all of these, you're going to, x equals h is going to be the vertical asymptote. And then our old domain went from 0 to infinity, and now our new domain is just going to be 2 to the left. And since that's an asymptote, it gets a parenthesis. So our graph is going to look like this. In number 47, I'm going to start a new paper because it looks like I have a bunch of graphs to worry about here. Alright, in 47, I get 1 plus log base 2 of x. So what this is our k value. In logarithmic problems, a lot of times they'll put k out in the front, and that way you're not confusing, you're not sticking that +1 in with the logarithm, you're actually keeping it separate. So this is going to be up 1. So I actually kind of prefer to do the graph before I tell the domain and the vertical asymptote and the x-intercept. So we'll see. And I kind of like to, because logarithms are so new, I kind of like to have that parent function. I just kind of like to have it there so that when I do my my transformation, I can move that critical point, and then I can kind of visualize, okay, just because I move it up 1, my horizontal or my vertical asymptote doesn't move. It's still at x equals 0. And then my x-intercept, though, it's interesting. I've got to figure out, where is this point? It's somewhere between 0 and 1. So let me go ahead and solve my logarithmic equation and figure out where that point is. So I'm going to subtract 1 here, and then I'm going to put my equation into exponential form. So you see here 2 to the -1 equals x, and then it becomes obvious, oh yeah, 2 to the -1 is a half. So my x-intercept is actually located at 1/2, 0. And then my domain, I can look at my graph. Since my asymptote started at 0 and it went over to infinity, that domain stays the same. So when we have a k value, that just moves us up or down. It doesn't change our domain or our vertical asymptote, it just changes the x-intercept. In number 49, y equals 1 plus log base 2 of x minus 2. So now we're kind of combining both of those transformations in the same problem. So my parent function is here, and I'm just making a note. I'm going up 1, and x minus 2 tells me I'm going right 2. I'm going to go up 1 and then over 2. So that's going to be the critical point of my new graph. So since h is 2, my new vertical asymptote is going to be at x equals 2. My domain and my x-intercept are still up for grabs. Well, my domain will start at 2 to infinity. But so here is where I need to figure out. So there's an asymptote. So here's where I need to figure out what my x-intercept is. So I'm going to just work out my equation again. 0 equals 1 plus log base 2 of x minus 2. Subtract 1. Now I've got 2 to the -1 equals x minus 2. So 2 to the -1 is a half, plus 2 plus 2. So I'm actually crossing the x-axis at 2.5. So doesn't that make sense? On the last one it just went over 0.5. This one it's 0.5 over away from the asymptote. Alright, so how far do I have to go? To 53 odd. Oh, I skipped 51. Alright, so 51. Oh, good. Alright, so we just have some matching here. So 51 and 53 are matching graphs. So if I look at 51, it's log base 3 of x plus 2. So it should be the parent function shifted up 2. So looking back up here at the parent function, just going up 2. I should still have an asymptote at 0, so that's going to be choice B. And then in 53, I've got f of x equals negative log base 3 of x plus 2. So I've got 2 to the left and a flip over the x-axis. So if I'm looking at my picture, my choices, move my parent function left 2, so that is going to be choice D, it looks like. Okay, and then number 69, let's see what that is. So 69, we're given an e to the third equals 20.0855 repeating. So rewriting a natural log into logarithmic form would be like okay. So the way I think about these, and hopefully I will do a good job of going over this in class, anytime I want to get rid of an e, I take the natural log of both sides. So there's where I wrote in my natural log. And the natural log and e cancel each other out. So in this side, I get 3 equals the natural log of 20.0855. And that is an understood, the natural log has an understood base of e. So this is still the same thing as going from exponential form into logarithmic form. It's just because this always has a base of e, the base doesn't ever vary, is why I sort of think about it in a different way. So let's look at 77 and see if this is going to help us use a calculator to evaluate. So if f of x equals the natural log of x, and x in this case is going to be the square root of 42, I think this is not going to really help us because this is just a calculator problem. 1.87. And that's it for this homework assignment. We're going to have some more converting from logarithmic form in the next unit.